Oh, okay. Let's dive into this. Welcome to this explainer. Today, I'm putting on my business analyst hat, and, well, I want you to do exactly the same. We're going to be auditing a major manufacturing cost overrun to see exactly how top-tier managers use standard costing and variance analysis to actually drive their business strategy. So grab your notepad because we've got a bit of a mystery to solve together.
Right, so here is our core mystery for today. Let's call it the Sanchez Incorporated case study. I want you to imagine you're an executive and you're reviewing the July numbers for this car manufacturing company. You're looking at the budget and you see they originally planned $25 million to produce 150 cars. But at the end of the month, the reality on the ground was quite a bit different. Sanchez ended up producing 175 cars and they incurred $32 million in actual costs. So, I have to ask you, did the manager of Sanchez successfully control their costs, or did they completely fail? Honestly, just looking at these raw numbers, the budgeted totals versus actual totals, it's incredibly difficult, if not impossible, to tell. I mean, yeah, they produce more cars, so of course it costs more money. But did it cost the right amount of money for that extra production? Without a highly structured system to break down those unit costs, we're literally completely in the dark.
To crack this Sanchez mystery, we need to completely reframe how we think about standard costing. It's not just boring accounting. It is actually a dynamic four-step data analytics model built for executive decision-making. First up, it acts as a prescriptive analytic. It tells us what the cost should be in a perfect world. Second, it's descriptive, meaning it calculates the actual real-world cost we incurred. Third, and honestly this is where the real detective work happens, it's diagnostic. By comparing what should have been spent with what was actually spent, we can perform a proper root cause analysis. Like, why do these two numbers look so radically different? And finally, it's predictive. We can use things like control charts and historical tracking to anticipate future performance. This whole framework, it's our ultimate investigative toolkit.
Now remember, step one of our model was prescriptive, figuring out what the cost should be. But you might be wondering, where do these standards actually come from? Well, usually companies look at two main methods. And to be honest, they both have some pretty big flaws. On one side, you've got historical experience. Look, it's a great starting point, but think about it. If your factory was highly inefficient last year, using that historical data just bakes those past inefficiencies right into your brand new standard. You're literally institutionalizing your own waste. Now, on the other side, you have engineering studies. These are incredibly rigorous. Engineers analyze exactly how the product is made to find the absolute most efficient approach. But engineers' standards are often way too strict. They essentially demand mechanical perfection from human workers, which just isn't realistic. That's exactly why the absolute best standard-setting process also has to include direct input from the operating personnel themselves, the actual people working on the factory floor.
And this brilliantly illustrates a really key concept. Think of setting standards kind of like throwing a javelin. In management, standards are generally classified as either ideal or currently attainable. An ideal standard is like aiming for the world record. It demands maximum efficiency and can only be achieved if absolutely everything operates flawlessly. No machine breakdowns, zero human error. Setting this as your daily goal? It can actually completely crush employee morale. But the currently attainable standard, that is like aiming for a personal best. It can totally be achieved under efficient conditions, but it makes sensible allowances for normal, everyday breakdowns and, less than perfect skills. From a management perspective, currently attainable standards provide vastly better behavioral benefits. When targets are challenging but actually reachable, your team will work so much harder to hit them.
So how do we take those attainable targets and assign them to an actual physical product? Well, it is exactly like following a super strict recipe for manufacturing. To figure out the standard cost for one single unit, say just one of those Sanchez cars, we have to make two firm decisions for every single input. First, there's the quantity standard. Basically, how much steel or how many labor hours should be used to build one car. Second, the price standard. How much should we be paying per pound of that steel or per hour of that labor? You just multiply the quantity standard by the price standard, and boom, you have your unit standard cost. We assign all our direct materials and direct labor costs using this exact recipe approach.
So let's bring it back to our Sanchez mystery. To figure out if management really succeeded, we need to look at the total budget variance. Your planned cost is simply what it should have cost for the actual output you got. Since Sanchez actually produced 175 cars, we take our perfect standard recipe cost for one car and we multiply it by 175. That gives us our fair baseline. Then we look at the actual cost. This is literally what was spent out of pocket, the actual price paid times the actual quantity of materials and labor that were used up. The difference between those two numbers, that right there is your total variance. It tells us exactly how far off reality was from our perfectly planned recipe.
Now what's really interesting here is that a total variance all by itself doesn't actually tell a manager what they need to fix. If we spent an extra $1 million, we still have to ask, why did we spend it? We absolutely have to split that total variance into two distinct pieces. First, we have the price variance. Did we spend more simply because the raw materials or the labor rates were just more expensive than we originally planned? And second, we have the usage variance, which is also known as the efficiency variance. Did we spend more because we used way too much raw material, or maybe because our workers took way too many hours to finish the job? Linking these two elements conceptually is absolutely crucial for proper business decision modeling, because it tells you exactly where the bleeding is actually coming from.
Once we've split the variance, it is time to play business investigator and start lining up our suspects. We really need to identify the root causes of these cost deviations. So, if we find a massive price variance, responsibility almost always falls straight on the purchasing department, or maybe human resources. Did they negotiate poorly with their suppliers, or did they have to pay premium rush rates because of some sudden shortage? On the other hand, if we have a massive usage variance, responsibility points directly to the production department. Was the factory machinery uncalibrated, causing a bunch of wasted scrap metal? Did the production manager use highly paid skilled workers for super basic, low-skill tasks? Look, by assigning responsibility this way, we aren't just pointing fingers, we're finding the actual root cause, so we can finally take corrective action.
But here is a really critical piece of advice for any manager out there. You absolutely do not need to investigate every single variance. Because of random variation, your actual costs are almost never going to equal your standard costs down to the exact penny. It just doesn't happen. Instead, what you do is establish an acceptable range of performance. You set top and bottom control limits around your standard. If a variance pops up but it's safely inside those limits, you just assume it's random noise and you'll leave it alone. You only sound the alarm and launch a full investigation when a variance falls outside of those control limits. And as a general overarching principle of business strategy, you only undertake that investigation if the expected benefits of fixing the problem are actually greater than the expected costs of going out and finding it.
So, the crucial point is that standard costing isn't just about accountants policing budgets. When it's implemented correctly, it provides massive strategic value to executive decision makers. By having standard costs ready at any time, a company doesn't have to wait until the very end of the month to know its baseline costs before making a strategic move. This enables truly proactive planning. It allows for accurate, highly fair performance evaluation, so we can finally look at Sanchez Incorporated and say, okay, producing 175 cars should have cost this much, and you spent $32 million. Let's open the hood and see exactly where you overperformed or underperformed. Standard costing is genuinely the only tool that lets us uncover the real truth behind those raw numbers, which ultimately enables dynamic product pricing in the market. And honestly, that is exactly how a real business analyst solves the Sanchez mystery.
Before we wrap up, I want to leave you with a final, somewhat provocative thought to chew on. In variance analysis, a favorable variance simply means that your actual costs were lower than your standard costs. Naturally, people love seeing favorable variances, but I want you to really ask yourself, if your cost variances are always perfectly favorable month after month after month, are your currently attainable standards actually driving excellence? Or are your standards just set way too low, masking widespread operational complacency? It's a really fine line between an attainable target and an easy one. Take a hard look at your own operations and see where your standards really lie. Thanks so much for joining me on this explainer, and keep asking the tough questions.